Hey guys, so welcome to our CE2450 SI session number 9, the midterm review. Okay, your favorite. This session is going to be a little different because this one I actually formatted the way that he would ask the question on the test. So I just want to get you guys a sense of feeling that like what the test is going to be like because the time is short and you have to answer 4 problems in like an hour, and the free response problem probably takes up to like 30 minutes. And his exam, like, I won't say it's hard, but it covers everything pretty much. So you have to understand the materials in order to get a good grade on the exam. Okay. So for this SI session, I'm just gonna first thing obviously like this first page, I'm gonna talk to you about like what kind of problem he's gonna put on the exam and what are some of the topics that you have to focus on. And also after this page is going to be some concepts, and then we'll go straight into our problems. Okay, so this exam covers from book session 2.1 to 4.7. Let me change the color. Okay. Yeah, 2.1 to 4.7. So basically from 2D vectors to what you have learned up to a couple moments, I believe. Yeah. Uh-huh. And if you want some extra practice on YouTube, I found this channel that is extremely helpful when I took this class. This channel link called Final Answer. I include the link right here. So if you guys download it as a PDF file, I think you can just copy and paste the link and watch the video. I mean, this channel is extremely helpful. It helps me a lot when I took this class. Okay, so one midterm covers. Okay, midterm covers 3 multiple choice and 1 free response problem. So 3 multiple choice, I think in a revised schedule that he sent out, he said the 3 multiple choice is going to be 1 2D resultant force. So we know that 2D resultant force is basically just either use the parallelogram law or summation of the forces. Okay, so those things are important. And I think you guys should be a master at this, right? So I'm not going to talk too much about it, but I just want to let you guys know that like what's in the 2D force. Okay. Second problem is going to be 2D equilibrium system, like summation of the forces, spring, pulleys, ropes in tension, like can you balance out the system so that the system stay in equilibrium. So 2D equilibrium. Okay, so all you need to use is summation of the forces in X and summation of the forces in the Y direction for the 2D equilibrium. Okay, and then the third problem, couple moments. Okay, so couple moments we know that it's 2 exact same magnitude force, but they go into the separate, but they are facing opposite direction. And then to find out moment, it's basically just the force multiplied by its perpendicular distance right here. So moment is still the moment equals F the perpendicular. Okay, same concept. And then to determine the direction, like to determine whether it's a positive force or negative force, we don't really look at its we don't really look at this negative sign. What we look at is whether this force is rotated clockwise or counterclockwise. Okay, so imagine like you holding a wheel, and then if you turn it counterclockwise, it's positive force. If you turn it clockwise, it's a negative force. So for this force, so this force is going this way. And then if we follow its path, so it's going to rotate like that. And this one is going to rotate like that. So what kind of motion is that, right? It's a clockwise. So that this force will be a negative force, okay? Extremely easy concept, okay? So right now I'm going to cover what's on the free response. So free response is going to be a 3D moment problem, okay? And his free response usually asks you like either 4 or 5 parts. So it's like one big problem, and you have like 4 or 5 parts to solve it, and each part is based upon the previous one. Okay, so you have to solve the previous one in order to know how to do this the next one. Okay, so he will ask you something about the moment, about a point. So when he asks you to do moment about a point, it's nothing but just the cross product, which is m equals to r cross f. Okay, and then second part of the problem, he might ask you to find the moment upon an axis. Okay, so what that is basically still m equals but the unit vector multiplied by the R cross F, okay? And then we use triple scalar product for that. And unless the question state otherwise, then we always, then the cross product always give you a Cartesian vector form, okay? So like I hat, K hat, J hat. I mean, I hat, J hat, K hat, my bad. Okay, and then moment about x's, we use triple scalar product. And the final answer you find is going to be a single magnitude, okay? Okay. And then the last part, he might ask you like, to find the angle between two force vector like F1 and F2, and then we're going to use dot product. So we know that dot product is cosine, I think cosine inverse of F1 dot F2 vector over magnitude of F1 and magnitude of F2. And then, yeah, okay. So this is pretty much basically everything that I cover on this midterm exam, okay? And just some test tips and reminders. Okay, so this test is about an hour long, and basically you only have like, I mean, yeah, you only have, I won't say you only have 3 minutes to ask a question, but like you don't really want to ask questions as much as you can, because it's just a waste of time because you only have an hour and you have to finish this 4 problems. So, and read all the questions at the beginning. So like if you found a question that you really doesn't understood, then skip it. Don't waste too much time on it. Okay, it's time consuming, this exam. Okay, so focus on the higher weighted and quicker question, like easy multiple choice, or like you also want to focus on the higher weighted problem, like the free response, the one that like is time consuming. But if you know how to do it, then do that one first because it's time consuming. So you want to get that done. Okay. And Dr. Akoi's exam is predictable, but you have to put in the work. Like how much you put in is how much you're gonna get back. Okay. All right. And also, I'm not sure if he taught. I'm not sure if he tell you guys about it. For the multiple choice part of his exam, like you cannot guess the answer. If you guess it, you only get like, I mean, if you guess it and you get a right correct answer, you only get like half of the point, like half of the credit. Like let's say this problem is like 10 points, and but if you guess it, you're only gonna get 5 points. Like yeah, so you have to show the work, and also vice versa. If you show your work and he's seeing that like you're working towards a correct path, then even if you get the wrong answer, he's still going to give you half of the credit. Okay. All right. So this first page and the second page. Okay, just some concepts. Okay. I'm gonna go very quickly through this because you guys should be familiar with this. Like I wasn't intentionally gonna put this on this midterm review because I think you guys can go back and look at my previous SI worksheet. But I think it will just be easier for you guys to look over all these equations and concepts in this midterm exam review. So just save you guys some time, okay? All right, so concepts, 2D resultant for vector, like I said, parallelogram law. Like if I have if I have a force like that, okay, then I can also have a parallel force right here and also right here. Yeah, my drawing is bad, but you guys understand the concept, okay? So just parallel to it, okay? And law of cosine. So like I said, you use law of cosine where you have two sides know, and you also know the angle between A and B. Like here's A, here's B, and you know the angle between A and B, which is C, and then you want to find this third side, which is C, okay? And also law of sine. So use law of sine. We have two angles now, okay, and at least two angle and one sine is known, okay. And then 3D vector, and you guys need to know this for the 3D moment problem, okay. So coordinate direction angle, we know that if this 3D, I'm going to draw it. So if this 3D for us vector, like it's giving alpha, beta, gamma, like you can find this force vector by simply just multiply this force magnitude by the cosine alpha, cosine beta, and cosine gamma, and you're gonna get your force vector. Okay, and if you do not have all of your coordinate direction angle, then let's say if you're only giving alpha, but you don't know what, no, if you're giving alpha and beta and you don't know what gamma is, then you can simply just take cosine alpha squared, cosine beta squared plus cosine gamma squared equals 1. And if the alpha and gamma is alpha and beta is known, and then simply just solve for gamma in this equation. Okay, and then find the coordinate direction angle at the end. This is when you find out the force vector in Cartesian form and also the force vector magnitude. Then you can use alpha equals cosine inverse alpha, beta, gamma, cosine inverse of the corresponding component force vector divided by the magnitude of the force. Okay, position vector. We know that let's say this position A, this position B, and if I want to find a position vector, simply just take from where you started to where you ended. So RAB, simply just RB minus RA. Okay, and this is useful when you doing the this is useful to for finding the unit vector. My bad. Okay, so unit vector is simply just this position vector that you found divided by the magnitude of the position vector. Okay, and the last little thing about the 3D vector is the smallest angle between two vectors. So, like I said in the previous one, if you want to find the smallest angle between two vectors, simply just cosine inverse of this vector multiplied by this vector, and at the and they are all in Cartesian vector form divided by the magnitude of the Cartesian vector. Okay. All right, next thing up is the equilibriums. Equilibrium, always when we see equilibrium problem, draw the free body diagram and show all the labels and force, label all the known magnitude and direction known, label all unknown as a variable. Okay, so this is very important. Like he's gonna take a lot of points off if you don't do your free body diagram for equilibrium problem. Okay, and equation for spring, we know that is the force equal to the spring constant multiplied by the distance thing stretch. So F equals Ks, or sometimes you're gonna see Kx, X and S is basically just mean the same thing. Okay, pulley. So for pulley, we know that if this is the pulley right here, and this is tension 1 and tension 2, then if we neglect the friction loss, then we know that tension 1 is always equal to tension 2. And when you draw your pulley free body diagram, you always want the arrow to point in the tension direction. So you don't want your arrow to be like that. You don't want that. You want like this. Okay. Okay, to the equilibrium equation, like I said, guys, this equation is gonna be extremely helpful. Like you're gonna use this through a whole static class. So summation of force in the x direction, summation of other forces in the y direction. Okay. Moments in 2D, we know that moments in 2D is equal to moment equal to the force multiplied by its perpendicular distance. Like if the force doesn't generate any perpendicular distance to the point where you want to generate the moment, then the moment is simply just going to be 0. Okay. Directional moment determined by the direction of the rotation, how the force rotated the body about a specific point. Okay. Moments in 3D. So moments in 3D, we know that is R cross F. Then this is Rx, Ry, Rz, Fx, Fy, Fz. And guys, the order is extremely important. You always want your R on the top and your F on the bottom. If you flip it, then you're gonna get a completely different answer. Okay. So this one is for moment about a point. Okay. And then the second one is a moment about an axis. Moment about axis is simply just a unit vector multiplied by the moment by the R cross F. Okay, we're going to use triple scalar product for that. There's triple scalar product is also called vector analysis, but there's another method to solve for this one, which is called the scalar analysis. I'm not going to teach you guys about it in the SI session because it's pretty useless and it's pretty complicated that I don't want to get people confused. So that I'm just gonna teach you guys how to do the triple scalar product because the purpose of the SI session is to teach you the course material in the simplest form and most effective form. So I'm not gonna throw in something that is extremely complicated that I don't really how to explain well. Okay, and 2D couple moment, like I said in the previous one, is the direction. I mean, it's a two force facing same magnitude but different direction, and they're separated by the, and they are separated by their perpendicular distance, and that's how you find your moment of the 2D couple moment. And its direction of the force is dependent on whether two forces rotated clockwise or counterclockwise. Clockwise, negative; counterclockwise, positive. Okay. All right. I think that's all for the concept, and we'll start our problem number 1.